What's up YouTube? Welcome back to my channel, and in this video we will be learning about quadratic patterns or quadratic sequence, if you want to call it that. So the objective of this video is for you to be able to identify quadratic sequences, use the quadratic formula, and use that formula to predict the unpredictable future. So how do we predict an unpredictable future? Stay till the end of the video and you will be able to find out. So let's say hypothetically we're given a pattern like this, right? And we're told to predict what the next term will be. So obviously with an arithmetic, what we will do is to search for a common difference, right? And we know that the difference between these two will be 6. And the difference between 6 and 20 is 8. And the difference between 20 and 30 is 10. So with a arithmetic sequence, often when we try to find the difference, it will be a common value. The value won't change. It will either be 2, 2, 2, 4, 4, 4, so on and so on. But in this case, we don't have a constant difference, or to say we don't have a constant first difference. If you look here, the difference between the first and the second term is 6, the difference between the second and the third term is 8, and the difference between the third term and fourth is 10. So we don't really have a common difference. So how we will be able to use this and how we'll be able to identify what the next term will be if the difference is not really common. We know that we can't just add 6 to get the next value. We can't just add 8, or we can't just add 10. It always changes. So in this type of scenario, what we do is we always look for a second difference. So now that we've determined what the difference, the first difference is, in this case, this is called the first difference. I'll just say the first diff. We always look for what we call a second difference. The second difference is key for us to be able to determine the general formula for this type of pattern. So we know that the difference between 6 and 8 is 2, and obviously the difference between 8 and 10 is also 2. So now we have our second difference. Our second difference is the one that has a constant difference, or is the one that we call a constant difference. It's the one that we call a constant difference, right? So this one is the one that we're basically going to use in order for us to calculate the general formula. So how do we use it? So bear with me here. This is a very long and complicated process, so I'm really going to need you to bear with me. As we've already said, in this video we'll be covering quadratic sequences, and if you've seen if you've done quadratic equations and whatnot, we know that the general formula for quadratic pattern, sequence, or equation, it's in terms of equations, it would have been ax squared, but in this case we say an squared plus bn plus c. So for us to be able to use this formula, we need to determine the value of a, b, and c, right? So there's a series or a sequence of ways in order for us to be able to, that we need to apply in order for us to be able to determine the value of a, b, and c. So the first thing that we need to do is to use the second difference. So how we use the second difference is we say 2a is equals to the second diff. It's equal to the second diff. So in this case, we know that 2a is equals to 2, right? And for us to be able to find a, we just have to divide both sides by 2, and we know that a is 1. So I'm just gonna rewrite that in the next page so that you guys are able to see. We say 2a is equals to the second difference, and we've already seen that our second difference in that formula was 2, and we're just going to divide that by 2. Sorry, Divide that by 2, and we know that that will give us 1. So now we've determined the value of A. How do we determine the value of B? So the second step to determine the value of B, we say 3A plus B is equal to the first difference. The first difference. Well, hold on. The first difference wasn't really constant, right? So we had the first difference here. We found it 6, 8, and 10. So which value do we use? We always use the first difference of the first two terms. So in this case, the first difference of the first two terms was 6, and we're just going to say 3A plus B is equal to 6. And we've already determined the value of A, so we're just going to substitute that. And in this case, we have B as the unknown. So we know that 3 times 1 is 3, and we're just going to transpose that, meaning take it to the other side, and that will be 6. And if you take it to the other side, it will obviously change signs. That we have 6 minus 3, and B is equals to 3, right? So now that we've done that, we need to find the value of C. So to determine the value of C, we need to say A plus B plus C is equals to the first term. The first term, and in this case, the first term was 6. So we're just going to say A plus B plus C is equals to the first term. And we're just going to substitute the values that we've already got. And we know that A is equals to 1, B is equals to 3, and we're looking to get C. And we know that everything is equal to 6. So if we add these two, we're going to get 4. Let me just change color. If we add these two, we're going to get 4 plus C is equals to 6. 4 plus C equals to 6. And we're going to transpose the 4. We have 6 minus 4, which equal to 2. Which equals to 2. So now we've determined the value of A, B, and C. So the next thing that we have to do is basically substitute that to our general formula, which goes like an squared plus bn plus c. And if we substitute that, we know that A was 1, so we'll just write n squared. B was 3, so we'll say 3n, and our C was 2. So this is the formula that we're going to use in order for us to determine the second term. But let's say hypothetically we made a mistake during the whole process of getting this formula. How can we determine if this is the right formula, or how can we know that this is the right formula? We can now substitute n as the known term. So we already know that the first term was 6. So we're just going to substitute the first term and in the n as 1 in this case, and see if we do get 6. If we do get 6, right? So we have 1 plus 3 plus 2, and obviously that gives us 6. And let's see if it works for the second term. If it works for the second term, and if we're going to substitute 2, here we have 4 plus 6 plus 2, and that gives us 12. And if we see from our pattern, we can see that the second term is 12. And obviously, you're going to try that again on the third term to kind of validate your answer, to validate that the formula really does work. But in this case, we're not going to, because I've already tried it by myself and I know that this is the right formula, right? So now they want us to determine what the value of the fifth term is. The value of the fifth term is, right? So where there is n, we're just going to substitute with 5. We're just going to substitute with 5, and that will give us 5 squared plus 3 times 5 plus 2. And if we simplify that, we have 25. 5 squared is 25. 3 times 5 gives us 15. And obviously plus 2, that gives us 42. So even if they were to ask us determine the 100th term, the 100th term, we'll be able to get it using this formula. And in this case, we'll just substitute 100 squared plus 3 times 100 plus 2. And if we simplify that, we're going to get 10,000 plus 300 plus 2. So that gives us 10,302. 302. So now, if going back to the objective of the video, we were able to identify what we call quadratic patterns, and the way to identify that is quadratic patterns always have what we call a constant second difference. They have a constant second difference. So if you find a pattern that doesn't have a constant first difference, always look for a second difference and try to see if that second difference is constant. And in this case, we obviously found that this equation has a constant. This pattern has a constant second difference, and we were able to identify a quadratic pattern using that. And from our example, we were able to use that quadratic formula in order for us to determine the next term or to predict the unpredictable future. And part of the reason why I say it's an unpredictable future is because you can't really predict where the pattern is going unless we have or you use the formula. It's very tough for you to be able to predict the next term because the difference is not really constant. So that's basically how we generally use this formula. So we're just going to do one more example to solidify our knowledge, and that will be it for this video. So in this example, we're given the following pattern: 5, 10, 18, 29, and 43. So the first question says determine the general formula. So here they basically want you to calculate or determine the value of Tn, and the second question says hence calculate the nth term of the value 263. So basically here they just want you to find the nth term if Tn is 263, right? So for us to be able to do that, the first thing that we need to do is obviously determine the general formula. So to determine the general formula, we're going to need the general formula being Tn. We're going to need to find the differences or to determine what type of pattern this will be. And to do that, we need to find the difference between T2 and T1, and we know that that is 5. And the difference between T2 and T3, that will be 8. The difference between these two will be 11. And the difference between those two will be 14. So from this pattern, we can tell that already this pattern is not an arithmetic pattern because the difference is not, the first difference is not constant. So we're going to try to see the second difference. We're going to try to see the difference between 5 and 8, that is 3. The difference between 8 and 11 is 3. And the difference between 11 and 14 is 3. So there is a constant second difference. And from that, we can tell that this is a arithmetic, it's a quadratic pattern. It's a quadratic pattern, right? So I'm just going to rewrite that pattern again here. It was 5, 10, sorry. So it's 5, 10, 18, 29, and 43, right? So, and we did determine that we do have a constant second difference of 3. This is 14. We have a constant second difference of plus 3. So from that, we can tell that this is a quadratic pattern. So we know that the general formula for a quadratic pattern is an squared plus bn plus c. And in order for us to be able to use the formula, we need to find the value of a, b, and c. So to determine the value of a, we need to know what A stands for, and A stands for the second difference. The second difference, which is the one that's always constant. In this case, we do have a constant second difference of 3. So we're gonna say sorry, it's not, sorry, I made a mistake. This is not a, it's 2a. So it's 2a. So that's how we determine the value of a. We need to say 2a is equals to 3. So in this case, we're going to divide both sides by 2. And here we're going to have 3 over 2. 3 over 2. So to determine b, we need to say 3a plus b is equals to the first difference. First difference. And in our case, the first difference is 5. So we're going to say 3 times, and we know that the value of a was 3 over 2 plus b equal to 5. And if we multiply that out, we're going to have 3 multiplied by 3, which gives us 9 all over 2 plus b equal to 5. And if we transpose that 9 over 2, we have, so for me, my trick when it comes to obviously simplifying fractions and stuff like that, I like writing my whole numbers as fractions as well with the base of the fraction. So in this case, I know that 5 can be rewritten as 10 over 2 minus 9 over 2, which simplifies the whole process. And I know that in that case, I have half as my value. So to determine c, we just need to say a plus b plus c equals to the first term. And if we go back to see what the first term was, it was also 5. We're just going to substitute 5 there. And we know that a is 3 over 2. B is half. And we're trying to find the value of c. So 3 over 2 plus half will give us 4 over 2 plus c equals to 5. And we know that 4 over 2 is equals to 2. So if we solve that, we're just going to transpose the 4 over 2. So we have 5 minus, and as I said, 4 over 2 equals to 2. So I'm just going to write that as 2. So c equal to 3. C gives you 3. So now that we've determined the value of a, b, and c, we just need to substitute them back into the formula. So in this case, we know that a was 3 over 2n squared. And then bn, what's the value of b? The value of b was half n plus, and c was 3. So this is the formula that you're going to be using in order to determine the next term, right? So we've already answered question number 1, which says determine the general formula. And in order for us to test if that general formula is true, we just substitute t1. And if you substitute t1, that will give you plus 3. This gives us 3 over 2. As we know that 1 squared is 1. And 1 multiplied by 3 over 2 gives us 3 over 2. And plus, we know that 3 times 1, half times 1 will give us half. And plus 3. So this gives us 4 over 2 plus 3, which is 2 plus 3, which gives us 5. So you're obviously going to try that with the second term as well to kind of solidify or confirm your answer. And then you'll be able to determine or solidify or basically kind of confirm that the general formula that you were able to get is the correct general formula. So we've already answered question number 1, and question number 2 says hence. Hence basically means that from the previous question, right? From the answer of the previous question, calculate the nth term of the value 263. So what they're basically asking from us is that Tn is equals to 263, and they basically want us to calculate the value of n. So now that we know that Tn is equals to 263, we're just going to say 3 over 2 n squared plus half n plus 3 is equals to 263. And we're going to use that formula to determine the value of n. So in this type of situation, I really don't like working with fractions. So to solve that, I'm just going to multiply every single term by 2, by the denominator, to kind of simplify everything. But before I do that, I'm going to transpose this 263 to the other side, right? So I'm going to have 3 over 2n squared plus half n. And obviously, if I transpose that, I'm going to have minus 263 equal to 0. And obviously, these are like terms, and we can solve them to get the value of minus 260. We will solve them to get the value of minus 260. And if I rewrite that, this is what I'm going to have. Minus 260 equal to 0. So from here, I'm going to multiply everything by 2, and I have 3n squared plus n minus, and this multiplied by 2 will give me 520. Will give me 520. From here, I just need to basically factorize this, and I know this is going to be a long process, but I'm just going to pause the video, simplify it, and then get back with the answer. So if I factorize everything, I'm going to get 3n plus 40 and n minus 13. And if I simplify this, I have n equals to minus 40 over 3, and n is equals, or n equals to 13. So if it was just factorizing or solving an equation, this would be sufficient enough for me to kind of solve. But let's basically explain what this means, like what this means here, right? So what we're basically saying is that the term, or the nth term of a value that's in this case, what was our value was 263. 263, yes, it was 263. The value of the nth term is minus 40 over 3. That's like calculating distance, right? We're saying from one point to the other, we have a value of negative 40 over 3. That's not really possible, because the moment we start traveling, we're adding. So we'll never get a negative value, right? We'll never get a negative value. We'll always get a positive value. So this doesn't really make sense. This value doesn't really make sense. So what we do in this type of situation, if we have a value that doesn't make sense, if it's a fraction or it's a negative value, in this case it's a fraction and a negative value, we just say this value is not applicable. This value is really not applicable, and not applicable is just NA, you know. Or we can just say no solution in that situation, and we just say this will be our solution. N is equals to 13. So if you substitute 13 into the formula, here we have 3 over 2, 13 squared plus half 13, and C was 3 plus 3. Do we get 263? Let's just put that in our calculator, and if we put that in if you put everything in our calculator, we get 263. We get that T13 is 263. So this is the value that we're gonna get if we substitute, and I hope this was sufficient enough for us to be able to identify quadratic patterns, be able to calculate the general formula, and predict the unpredictable future. So I just want to go back to the first page where we determine the objective. As I said, the objective was for us to be able to identify the quadratic sequence, use the quadratic formula, and predict the unpredictable future. And from what we've done so far, we are able to utilize the quadratic formula to predict the unpredictable future. So that is it for this video. If you really liked this video, please hit the like button, share, subscribe, comment if there's anything that you'd really want us to add in any of our videos, if there's anything that you'd like us to talk about, or any topic that you'd really want us to cover. Just comment below If there's any errors that you'd like to correct or anything that you'd like to discuss about this video, just comment as well. But that is it for this video, and I will see you in the next video.